All right, y'all. So this is a new unit, and so we're starting with 5.1, which is graphing exponential and log functions. So this is not new. Now you're going to see it looks a little bit new because we're getting rid of the e value, but what you're going to see is that it's really not new. So I'm going to flip this over and just kind of a little bit of review. If I want to graph y equals e to the x, so this is my exponential function, what happens is, remember, I have to have this asymptote, and this asymptote happens at y equals 0. And then I have this point right here at 0, 1, and my graph in my standard form looks like this. Okay, so this is positive e, positive x, and my graph would look like this, so exponential growth. If I have my log function, it doesn't matter if it's log x or ln x. They're going to look exactly the same. Remember, now my asymptote happens in the vertical. It happens when x equals 0. And I have this point right here that's at 0, 1. So at this point, and my graph would look like this. Okay. Now, these two shapes are super important because this, even though we're changing from an e here to a value, or we're going down here and we're changing to a log that looks a little bit different. We have a base now. The shapes are going to be the same, and they're still both going to have asymptotes. Okay. Now, in chapter 4, we talked about what happens when we have negative e to the x. So this is going to be the opposite of y. And if I have e to the negative x, this is going to be the opposite in the x direction. So, just kind of a quick little sketch. If my graph normally looks like this, if I'm going opposite in the y direction, my graph is going to look like this. And with an opposite in the x, or a negative x value, if my graph is going up, now my graph is coming down. And I still have the asymptotes. I didn't draw them, but just kind of a little summary. Remember, if the negative is outside here, it applies to the y values. And if the negative is on the exponent, it applies to the x values. Okay, same thing over here with our logs. Okay, so what does this look like? So I'm going to actually show you on my calculator because I think it does a better job. So don't get jammed up with the fact that this is not an e anymore and it's a 4. So if I go in here and I graph e to the x plus 2, and then on another function, I'm going to graph 4 to the x plus 2. What I have here is I have my standard exponential that I know is moving up 2. So I know right away I'm going to have this asymptote right here at y equals 2. That's from last chapter. Oh, hold on. Good thing I checked this. And so now what I have is I've graphed my new function, and I've graphed what I know about my exponential function. And look what happens. So blue is the exponential, red is the new function. So that's the exponential. And this is my new function. Oh, sorry, I got kind of a glare on this. Let me see if I can make this a little bit better. So what we see is that the graphs track really similarly, and we just have a little bit of an offset here because one is the value of e and one is the value of 4. Okay, so we're not going to worry so much about what the offset looks like. We're just going to worry about where we're crossing our x or our y axis and where my asymptote is. So I know I have this asymptote at 2, and I know that this value that I'm going to have right here is 1 up from my asymptote, and here is what my graph is going to look like. I see that right here on my calculator. Now, here's the other thing that I want you to remember. Remember, anything to the 0 power is 1. So if I take this value right here and I say 4 to the 0 power, which means the value that is on my y-axis. So when x equals 0, that's my y-axis. If I plug in 0, I would have 4 to the 0 plus 2. Anything to the 0 power is 1, so 1 plus 2 is 3. And if we count this, 1, 2, 3, that's where that point is. So this is just another way to check and make sure you have your points correct on here so that we don't... so that your starting point of where you cross that axis is going to be correct. Okay? All right, so let's look at this next one. So now what I know I have is I have a value that is going to be negative in the y direction, and I have this shift to the left by 1. Now, I do know that I have no value that's out here. So because I have no value out here, I have my asymptote happens at 0 still. So my asymptote's going to happen at 0. And now I have this value here of -3. So this value of -3 is going to be right here. And then I'm going to move one value to the left. So this one value to the left tells me that I'm going to shift to the left by just one value. And so if I want to know where I'm at -1, my value here at -1, I'm going to get this value at -1. So I have this value here, and I'm going to go at -3, and my graph is going to look like this. Okay. Now, with this one, I know I have an asymptote at 1. This tells me that my graph is going to shift to the right by 2. So in this case, I'm going to go to the right by 2. My base here is just 2. So if I say x minus 2, and then I have this +1 value, then I know that my graph is going to go 2 to the right and up 1. So here's the value that I'm going through. Now, let's talk about this. Remember, I could take this value and I could make it 0. So to make this 0, it would be 2, which is what I know I have because I go to the right by 2. So I would have 2 to the 0 plus 1, which is 2. And if I look at where this point is, this point's at 2. All right, so this one is super easy. I have this asymptote at 2. I go up 1 from my asymptote, and it's just a standard exponential curve. Okay, here I have no vertical shift, so I have nothing that's over here. Okay, this tells me that I'm going to flip over. My y values are negative, so instead of being above the x-axis, I'm going to be below the x-axis, and I'm going to shift to the left by 1. So my graph is going to look like this. Okay, here I have my asymptote at 1. This tells me I'm going to shift over the x-axis. So instead of my graph looking like this, my graph is now going to look like this. Okay, and it's easy to, sometimes if you just want to sketch your parent graph and say, okay, this value becomes -x, so it's going to move to this side. All right, so now let's talk about log functions. So I'm going to do the same thing that I did here a minute ago, and I'm going to pull my calculator back out, and I'm going to look at this graph, which is log of x plus 1. So this is my standard graph, and what I know is that my asymptote is going to shift, and I'm going to have this asymptote here at -1. Okay, and so this is what my parent function would look like, right? So I have this asymptote that happens right here. The graph doesn't show it, but it approaches the asymptote, and I have this curve. Now, I'm going to show you a new function on your calculator. So if you notice, this has log with a little 3 down here, and the way we read this is log base 3. I have a base now of 3. So from your calculator, the only two buttons that you have on your calculator are log and ln. But I can graph any base. So what happens is I go here to math, and then I'm going to arrow all the way down to where you see log base. And when you hit log base, it brings this up. So I want log base 3. And then I'm going to put my transformation in there, x plus 1, and I'm going to graph these. So blue is my standard log function, and red is going to be my transformed log function with a base of 3. So again, you see that they're super similar, that these two points are really similar. So what I know here is that with my standard graph, I'm going to go through this point of 0, 0. And my graph is going to look like this. So the only thing that this told me is that I have this asymptote at -1. Okay? Okay, so this tells me that I have my asymptote at +2. It's all going to be on this side of the graph, but now I'm going to go up 3. So 1, 2, 3, and this is going to be the point that I'm going to go through. And I didn't show this, but whether it's, in fact, let me just do this real quick. If I go in here and I do this, ln of x plus 1, oops, sorry, made a mistake there. Ln of x plus 1. Now I've got my log, I've got my log base 3, and I've got my ln. And we're going to talk more in the next lesson on the difference really between all three of these. But if I graph this, you see that this other line graphed right over the top of it. And so, again, it doesn't matter. Okay, so here we go with this one. So there's no transformation on the inside here. So this tells me that my asymptote happens at 0. Now, instead of my graph happening on this side of the x-axis, it's going to happen on this side of the x-axis, and I'm going to go up 1. So my graph is going to look like this. Okay. All right, couple more. So with this one, I have an asymptote at positive 1. That's because of this. This tells me it's opposite y. So if my normal graph would look like this, it's going to be the opposite y graph. So what that's going to look like then is this. So these tall values that I had up here are now my negative values. Okay, last one. Nothing happens on the inside. So I have this asymptote here at 0. If my normal parent function looks like this is going to give me an opposite of the y value and then an opposite of the x value. So I have a negative ln, so a negative y, and then I have a negative x value. So what that one's going to look like is, I'm going to go through this point right here, and it's going to look like this. So these values become opposite, so they come over here, and instead of it increasing, we're going the opposite direction, so they flip over the y as well. Okay, so what I would tell you as you get familiar with these, try to sketch them on your own and then go back in on your calculator and just double check them. And if you want to just, dash in what your parent function looks like, that might be easier. Okay, now what we already know is if we look at an exponential graph, so we look at something like this and we look at a logarithmic graph like this, the shapes are very similar. We have an asymptote in the y, or we have an asymptote that's vertical in the x, but we know that the shapes are similar. So what this is saying is sketch the parent functions e to the x and ln x. So if I'm looking at just e to the x, and I'm not going to draw my asymptotes here just to kind of keep it a little bit cleaner, and then I sketch this one, ln x, this point is at 1, 0, it looks like this. Okay, so what we notice is that these two shapes are real similar, and it says right here, how do the domain and range of the critical points on the exponential functions compare to the logarithmic functions? So we know that this critical point right here is 0, 1, and we know that this critical point right here is 1, 0. We know this because that was part of our parent function graphs last chapter. So what we see is that these are flip-flopped. So how do so let's not talk about domain and range. Let's just talk about critical points. So when we have these critical points, we go from 0, 1 to 1, 0. And so the x and y values switch. Right? So if this was 0, 1, now this is 1, 0. I could pick other points on here and I would see the same thing, right? Now, if we look at domain and range, remember my exponential has my asymptote here. So my domain of my exponential function, so my domain of my e to the x function is going to be negative infinity to positive infinity. And my range on my e to the x function is going to be 0 to infinity, right? So here's my asymptote. I can't cross it, so it starts at 0 and it goes up. Now, if I look at my ln of x function, my domain on this one, my asymptote is here, right? It's up and down. And so my domain on this is going to be 0 to infinity. And then my range goes from negative infinity to positive infinity. And what I want you to see is that these are also just flip-flopped. The domain and range is flip-flopped, and the critical points are flip-flopped, right? So we're switching our x and our y. Now, the reason that we do this is because these are inverse functions. So this last part says, draw the line y equals x. So y equals x is a line that goes through the origin and has a slope of 0. So this is y equals mx plus b. My slope here on this graph would be 1, and my intercept here is 0. So I start at the origin, 0, 0, and I go up 1 over 1. So what we notice is that if I was to take my paper and fold it in half on this dashed line, my graph here reflects over that dashed line of y equals x. So what happens is functions are inverses of each other when the graph reflects, and if you remember reflects, that's the same as saying it flips, over the origin. And the origin would be this line right here. We're not saying that flips over y or x. It flips over the origin, which is the graph y equals x. So what we can say are exponential and logarithmic functions are inverse functions. So all this is saying is we can flip-flop our xy values, we can flip-flop our domain and range, or we can reflect this over the line y equals x from here to here. Okay, now let's talk about what this looks like if we have inverse functions that are not a graph that we know, like this one. Okay, so this nomenclature right here, and I'm going to highlight this because this is important. This nomenclature just tells us that we have the inverse of the function f of x. That's what this tells us. So if you see this, f to the negative 1, this doesn't mean we move it to the denominator. Normally when we see a negative exponent, we would move this to the denominator. But because it's on our function notation, we would say that this is an inverse of f. All right? So we know that e to the x, so the function e to the x, the inverse of e to the x is ln x. Okay, so we can look at any shape. Like I can look at this shape and I can create an inverse of it. And I know that because up here I said I can change my points. So if I have this point right here, which is 1, 2, 3, so this is negative 2, 3. And I have this point, which is 2, 3. And I have this point, which is 7, negative 2. Hold on. This point is 7, negative 2. And this point, 6, 7, 8, 9, is 9, 0. Okay, I can take this graph and I can find the inverse of this. So all I'm going to do is I'm going to use a different color here. I'm going to regraph this and I'm going to switch these. So in a normal graph, this is my x value and this is my y value. But to create the inverse, this now becomes my x value and this becomes my y value. So this point right here happens at 3, 2. So it's going to go right here. And this point happens at 3, negative 2. This point, I didn't mark this on my graph, but this point is 5, 0. This point becomes 0, 5. 1, 2, 3, 4, 5. So it's going to be right up here. Okay. This point is now negative 2, 7. So if I go negative 2, and this graph is definitely not big enough, but if I go negative 2, 7, I'm going to have a point that's up here somewhere. And then this point is 9, 0. So now it's going to be 0, 9. So it's going to be clear up here. All right. So if I was to look at this, and remember I've got this to create an inverse, what I want to do is I want to see if I create, if I flip it over this axis of y equals x, is it really an inverse? So here's what I have if I connect the dots. I have this point, I come down here and hit this point, and then I go down here and hit this point. So this is what my graph would look like. So if I flip it over this axis of y equals x, this is what my new graph looks like, okay? So I can do the same thing over here. So if I take this point that I have this point that happens at 0, -1. So if I regraph this point, it now happens right here at 1, 0. This tells me that I have an asymptote at y equals -2. So now I'm going to flip this asymptote, and this asymptote is going to happen at x equals -2. Like this. So my new graph is going to look like that. Okay? Now, if I take this dashed line and it goes in between the two, if I fold this on top of each other like this, does this model over this line of y equals x? So, key to these is just take whatever ordered pairs you have and just rewrite them and graph them, and I'll see what I can do about making sure that you can graph it actually on the graph. Okay? All right, so this first homework is just going to be a lot of practice graphing exponentials and logs.